So first thing we want to do, we want to store this value, right? So I can say integer, let's say m is equal to a top, right? So we want to store this value, then we want to decrement the top. Let me do this. So in this case, like m becomes equal to 30, decrement the top. So top was equal to 2, now becomes equal to 1. So top moves here, right? And then we want to return 30. So that's what we want to do, return m. Okay. So like we returned the top value and we moved, like we moved the index. Sorry, we moved the we changed the top value, the top variable value to what it was before, -1. Okay, so some people like want to make this one 0, but it's not necessary, because if you push another element, you're gonna overwrite on top of this one. So there's no need to make this one 0 anymore. But if you want, you can do that, but that's not necessary. But this is like how we can implement the pop function. One way in C++, I can just like merge these three things into something like this: return a top minus minus. I hope you are familiar with the pre-increment and post-increment. Okay, so it means that we want to return a top, then reduce top, or like decrease top, right? In this case, it means that we want to increase top first, then return, or sorry, or put, then we want to put value d into a top. So this is pre-increment, this is post decrement. So if that's happened, like it means that like we're changing the top value into this index. So this is as simple as that. If you want to implement the peak, it's going to be very similar to pop. Let me actually maybe erase this one. If you want to implement peak, it's going to be very similar to pop, but we actually, like, we are not gonna decrease the value of top. We just want to see what the top value is, so we're just gonna return top. Again, if you want to implement the pop function, there's one thing that you have to check. What is that thing? You have to make sure that our array is not empty, right? So we have to make sure that top is, if it's -1, means that our array is empty. So we have to make sure that top is bigger than or equal 0. Bigger than or equal 0. So that's the requirement for the pop function. Again, you can see the difference between push and pop. This one doesn't return anything, but this one has to return. The difference between pop and peak is that in the pop, like when you do the pop, the top of the stack is gonna change, but in the peak, no, it's gonna remain the same. We're just gonna see the value at the top. So implementing a stack using array is as simple as this. It's not that difficult. Now let's see how we can implement a stack using a linked list, which is another data structure that we can use to implement stacks. Okay, so before that, let me actually draw a linked list. So you already see this linked list in our first class. So let's see this one more time. Let's actually just go up to 40. Okay, so we saw that in the linked list we always have a head pointer that points to the head of the linked list, and also the pointer part, or the, if we call this one, like let's call this structure node has an integer data, and it also has node star, let's call it next. Okay, some people also like the put a struct here, but that's not needed. Okay, so what the next part of each node stores is the address of the next node. Okay, so let's just give random addresses to these nodes. I'm just gonna like have this one, let's call this one 0x 1 1, this one 0x like 1 4, this one 0x f0, this one 0x fa. If you're not familiar with this, this is like a hexadecimal notation, so it's representing the address in the base 16. So this is going to be number 17, right? 1 plus 16. This one it's going to be 4 plus 16, 20. This one is going to be 0 plus f, which is 15, times 16. This one a, which is 10, plus, so this is going to be f, which is 15, times 16 plus 0. This one it's going to be 10 times 1 plus 15 times 16. Anyways, so this one it's going to store, so this head is going to store the address of the first node, which is going to be 0x11. This one it's going to have 0x14. This one 0xf0, this one 0xfa, and the last node, its pointer, it's going to be null, it's empty. That's how we know where our tail of the linked list are. Okay, excuse me. So so first of all, let's say that we want to push another number here. So we want to push number, let's say 50 here. And you guys think about this and tell me, or like think about it, and like you can't, like I can't hear you, but like think about it. Like, am I gonna insert 50 here at the tail, or am I gonna insert it here? Okay, so like in other words, is the top of the stack is gonna be here, or is it gonna be here? Which one? In order to answer that question, you have to go back to what we